In this video, we will describe modules and packages. A module is a file containing Python definitions and statements. Modules differ from scripts really only in intent. Scripts are intended to be run directly, while modules are typically meant to be imported into scripts or other modules. However, both are files containing Python code and use the .py extension. For example, the following code is included in the fibbo.py module that was included with this notebook, and it provides only two functions. One that prints the Fibonacci sequence up to n, and the other that returns that sequence up to n as a list. And to use these functions located in the module, we must first import them. To import the functions, I simply write import and then the name of the file, which in this case is fibbo. This line adds the name Fibbo to the global namespace. And if we want to use one of the functions from this imported module, we must specify the module name, fibbo, followed by a dot, and then the function name with its arguments. Now, it's recommended that all of your imports come at the top of any module or script, which can help readers to identify the needs of a code without having to read every line. Now, the previous import imported all names in the module Fibbo. But if you're only interested in working with a few names from a module, you can import them specifically without importing the entire module itself. And so to do that, we can write from, then the name of the module, fibbo, and then say import and give it a comma-separated list of the names you wish to import. In this case, we only wish to import the function fib. And now with this line, instead of adding fibbo to the global namespace, it actually adds the function fib to the global namespace. So now we can call the function directly without using the module name. With the syntax, we could still import all the names from a module if we wanted using the asterisk wildcard. However, do note that this will load all the names from the module into the global namespace, which may overwrite names that have already been added to the global namespace. And so this is another reason why it's recommended that all your imports occur first in a script or module. Importing also supports aliasing using the as keyword. This allows us to give our own names for modules, or any imported name for that matter. So for instance, I can write import fibbo as, and now I can give a new name. So maybe I want to use the name fib instead. And after this line runs, we can refer to the module with the name fib rather than the full name fibbo. And so in this example, it's sort of superfluous since we've only reduced it by one character, but many modules have much longer names. And so it's common practice to reduce those to much easier to type names. Likewise, we could specify an alias for a function that we import by from fibbo import the function fib as Fibonacci. And then we can write Fibonacci and pass 400. You see we get the same output. And so you see that Fibonacci is in our global namespace, and it refers to the function fib from the Fibbo module. And we stated earlier that there really isn't much difference between a script and a module. In fact, we can execute a module just as we would a script by passing the file name to Python as an argument, as you see here in the text. Now, the only difference between running a module this way and importing a module is that the variable underscore underscore name underscore underscore will be set to the string containing main with two underscores on either side when the module is executed via the Python command. Every module is given the variable underscore underscore name underscore underscore, which holds the name of the module itself. However, when a module or script is being executed, the value of that variable is set to main. Now, the current notebook is the main module, and so if we output the variable name, we see the string main is returned to us. Because of this, you'll quite often find modules that contain a conditional towards the end, similar to this one here, which checks the value of the variable name. And if it equals main, then it will run some special code. Typically, it's test code. But the reason you'll find this in many modules is that if you execute the module directly, you can run this code. If it's imported into another module, this code would not be run. And so using this for testing or some other diagnostics is quite nice, since it will only occur if you specifically run this module using the Python command and not when someone imports it. When importing a module, the interpreter must search for a module whose name matches the one you've given it. To perform the search, it first searches the set of built-in Python modules, and then it searches a list of directories specified by sys.path. Now, sys.path is something you can modify, but it's initialized to contain the directory containing the script that started the process, or the current one if there's none specified. It also contains the value of the environment variable Python path, which is simply a list of directory names, similar to your shell variable path. And then depending on your installation, it may search a set of additional directories. Now, typically this doesn't need to be modified unless you're supporting multiple environments. But if for some reason you have modules outside of the typical install locations, you can modify the environment variable Python path to include them in the search. Given a module, the directory function can be used to get a list of all the names contained in that module. So if I write dir and then pass the name of our module, Fibo, you see that it gives us back a list of strings, where each string contains a name from the module. The first set of underscored variable names here are things that Python provides for us when we create the module, and the last two are actually the functions that we specifically added to that module. If we omit an argument when calling the directory function, we actually get back the names in the current module. So you can see there's a great many more here, some of which were added by Jupyter Notebook itself as we were running the code blocks in this notebook. So in this next section here, I've given you a listing of several useful modules along with links to the documentation. This is by no means a complete list of the modules available to you. In fact, if you want a full listing, I've also given you a link here to the Python module index. Okay, so to wrap up this notebook, I do want to talk about packages briefly. A package is a collection of modules that are typically related or work together to provide some specific functionality. Packages help us to keep modules organized using directories to group similar modules. Also, since modules are located in directory trees, we access them using dotted module names. So for example, if we look at the sound package listed here, we'll see that the echo module, which is in the effects subdirectory of the sound directory, would be denoted as sound.effects.echo. And if we wanted to import that module, we would write exactly this: import sound.effects.echo. And of course, with this import, any call to a function in echo would require this long dotted name to also appear. So to get around this, we could use the import variant here from sound.effects import echo. And now each function call would only require echo dot and then the function name. And if we wish to shorten this even further, of course, we could use an alias as we did with the Fibonacci functions. Now, if we attempted to import everything from a package using an asterisk, then the entirety of the package is not imported, since this could actually take a long time and many resources depending on the size of the package. Instead, when a line like this is encountered, the special file __init__ is checked from the package folder. And in that file, the interpreter checks for the variable all. And if it's defined, like we have in this example here, then the import star or import asterisk will import only those items that are in the list defined by all. If this definition of all is not present, then the package name itself will be entered into the global namespace along with any other names that are specified in this file. This special file init is included in every directory in a package, and it actually tells Python that that directory is meant to be considered as part of the package. And it may also contain code to help initialize the package, as well as include variable names like all that we just talked about. Now, in the following section here, I've given you a list of packages that are quite useful, along with links to their documentation or home pages. Similar to the modules above, there's also the Python package index link here, which gives you links to more than 200,000 projects which have been made available by people in the Python community. So you can see that there's a lot of things out there, and hopefully this list given here will give you a good starting point